So moving on to your notes page right now, the sine function and the cosine function, which we're going to see in a minute, are periodic functions, which means that they repeat at exact regular intervals called cycles. Okay, so there are two things that you have to know about, how to identify in a periodic function. You should know how to find the period of a periodic function, and you should know how to find the amplitude of a periodic function. So how do you find the period? The period is the length of a cycle, and you can start at any point on the graph to find your period, but it's usually easier to pick the points of maximum. So this point and this point, the distance from this point to this point will be your period, or you could pick the points of minimum. So for example, if you picked this point and this point, the distance between them would be exactly the same as the distance between these two, right? Which would be your period. Okay, your amplitude. So your amplitude is defined as half the distance between the minimum and maximum values. Okay, so you would get the distance between your minimum and your maximum and divide it by 2. An easier way of visualizing it, at least I find it easier, I think several people find it easier, is you simply find the center line of your sine function, and you find the distance between the center line and the point of maximum, or between the center line and the point of minimum. All of these are going to have exactly the same values, and all of these will be equal to your amplitude. Now, we'll start graphing. The graph of sine, we already did it a few minutes ago, but I copied the unit circle here just for us to refer back to it. If you take a look at your graph, you don't have degrees anymore. All of the angles are in radians. You should remember that pi over 2 is 90 degrees, pi is 180, 270, and 360. And you're going to see that the x-axis of the cosine function is labeled in the same way, okay? You're also going to see that the y-axis over here doesn't go up to 1, it goes up to 5, right? But we know that the maximum value for sine is 1, so I'm already going to make my dashed line over here so we remember that our sine function, at least the perfect sine function, can't cross 1 or -1, right? Same thing for cosine. The maximum value of cosine is 1, and the minimum value for cosine is -1. So that's the space where my sine and cosine functions are going to oscillate, right? So let's start graphing sine. When my angle is 0, my sine function is 0, right? When my angle is 90 degrees, at 90 degrees over here, my y value is going to be 1, which means that my sine is going to be 1. Whenever we get my angle is equal to pi, pi is 180 degrees. So when I get to 180 degrees, the sine of 180 degrees is once again 0. 3 pi over 2, I get -1, 2 pi, 0, and so on. And I can complete my way the other way around, or I can look at my unit circle and figure it out. If I have -pi over 2, which is -90 degrees, at -90 degrees we go down, and my sine is -1. So let's graph that. -1. At -pi, I have half a circle again. I go up to 0. -3 pi over 2, my sine is 1. And -2 pi, my sine is 0. I can connect these points, forming my sine function, the graph of sine. What is the amplitude of the sine function? Well, the amplitude is a distance from the center line, which in this case is my x-axis, to the point of minimum or maximum. So my amplitude is going to be this distance over here. If we take a look at it, that's going to be equal to 1. To find the period, we have to find the distance between 2 points of maximum or 2 points of minimum. So I'm going to pick these 2 points of maximum over here, and this is going to be my period. Now, how am I going to find that value? It looks tricky, but it's actually not that tricky. So let's divide this into two pieces. The first piece is going to go from this point of maximum to 0. If I do that, I'm going to see that this distance goes from 0 over here, from 0 all the way to negative 3 pi over 2. So this distance is 3 pi over 2, right? And we have the distance from 0 to pi over 2, which is simply pi over 2, which means that if we add 3 pi over 2 plus pi over 2, we get the total distance. If you're having a hard time adding fractions, I don't think you should, because this is very straightforward. We already have a common denominator. 3 pi over 2 plus pi over 2, we're going to add the numerators and keep the denominator the same. This is going to be 4 pi over 2, or we can simplify that. Dividing by 2, I get 2 pi over 1, or simply 2 pi, which means that my period, the distance between those 2 points of maximum, is 2 pi. Let's go to the cosine function now. So for the cosine function, we're going to do the same thing. We're going to start when theta, or the angle, is 0 over here, and figure out what is the value of cosine when my angle is 0. So when my angle is 0, I'm at this point over here, and the cosine of theta is the x value. So at this point, the x value is 1. This means that whenever the angle is 0, cosine is equal to 1 over here. So you see, we start in a different place from the sine function. The sine function starts at 0, 0. The cosine function starts at 0, 1, right? So moving on, pi over 2. Whenever our angle is pi over 2, or 90 degrees, well, 90 degrees isn't here. The x-coordinate for 90 degrees is 0. So let's plot 0 over here. Pi degrees, or sorry, pi radians. If I have pi radians, I have 180 degrees. 180 degrees is all the way over here. The x-coordinate is -1, so we can graph that. -1. 3 pi over 2. 3 pi over 2 is 270 degrees. We go all the way to 270 degrees. The x-coordinate is 0. We can graph that again. And if we have 2 pi radians, that's going to be 360 degrees. We're going to end up at the same starting point, which the x-coordinate is equal to 1. So that's what we're going to graph, 1. And moving backwards, right? So if I have negative pi over 2, this is negative 90 degrees, which means we're going to go down up to negative 90. The x-coordinate on this point is 0. So let's graph that 0 over here. Negative pi over 2, or sorry, negative pi is negative 180, moving all the way to negative 180. The x-coordinate is -1. Negative 3 pi over 2, negative 3 pi over 2 is negative 270. Up here, the x-coordinate is 0. And negative 2 pi means we go negative 360 degrees, and the x-coordinate is going to be equal to 1. Now we can connect our points using the trig function. My function doesn't look that great. This kind of thing over here can't happen. Okay, it can't look like a V. It has to look like a curve, all right? Google sine functions and take a look at how the shapes of the sine functions look like. They don't look like V's, alternating V's going up and down, or W's. They actually look like curves, okay? The amplitude of the cosine function, same thing. We're going to have to find the distance between the center line of the maximum. In this case, it will also be equal to 1. And the period will also be the difference between 2 points of maximum. So I'm going to pick this point, and the cosine function is really easy to see that if this is 0, and this is 2 pi, then my distance is also going to be 2 pi. So my period is also equal to 2 pi.